of chemistry. I'm jealous of his style, but he's going to let me do chemistry with him anyway. All right, we're doing the on your owns for module 14, 14.7, and 14.8. Martin, will you please read 14.7?
A chemist runs a chemical reaction at 100 degrees Celsius and determines the instantaneous rate to be 0.12 molarity per second. She decides to speed up the reaction by running it at 150 degrees Celsius. What is the new reaction rate?
Okay, so in order to do this, we're going to look on page 478 where we see the bold words. Read those bold words.
The rate of many chemical reactions doubles for every 10 degrees Celsius increase in temperature.
Okay, so how many increases do we have? We go to 5. 10, to 20, to 30, to 40, to 50. So we have 5 increases, right?
Yeah.
So we're going to double. So
that's
how can we do this?
0.2 times 2 to the 5.
5th. That's right. So 2 to the 5th is, let's see, 2 times 2 is 4. Times 2 is 8. 2, 3. Right? It's 32. Yeah?
Yeah.
Okay.
Oh,
so we're going to multiply 0.12 molarity per second times 32.
Which gives us 3.84. Molarity per second.
Is that our final answer?
Yes.
Okay, so at 150 degrees, the instantaneous rate of reaction is 3.84 molarity per second. Okay?
Yep.
So now we're looking at 14.8.
In On Your Own problem 14.5, you determined that the rate equation for the following reaction, 2PO plus Br2, yields 2POBr, is R equals K open,
times the constant times the concentration
of PO squared times the concentration of bromine, 2, Br2. If a chemist runs this reaction at 25 degrees Celsius with reactant concentrations of 1.5 molarity each, and then runs the reaction again at 5 degrees Celsius with the same reactant concentrations, what will the reactant rates be in both cases?
Okay.
The rate constant for this reaction at 25 degrees Celsius is 1.12 1 over molarity squared times seconds.
Okay. So, using that same rule, we said that the rate of many chemical reactions doubles for every 10 degree Celsius increase in temperature.
Yeah.
So here it's going to do what?
Decrease.
It's going to actually halve, right?
Right.
Okay. So what we need to do is we need to find out the instantaneous rate of reaction at 25 degrees Celsius, and then we will calculate based on that.
Yeah.
Yeah. So here is the K at this. So I'm just going to calculate all this. So the instantaneous reaction at 25 degrees Celsius is 1.12 1 over molarity squared times second times, what's the concentration of the PO is 1.5 molarity squared times the concentration of 1.5 molarity.
Yeah.
Okay, so we'll end up with something in terms of molarity per second, right? And I'm going to take these squares, cancel each other. Let's do that. So 1.12 times open parentheses, 1.5 squared times 1.5 equals 3.78. How many significant digits should I have in this number?
2.
2. That's right, because I only have 1.5. That's only
So
2
that's
significant digits. So I'm going to record as 3.8 molarity per second. Okay. So if that's the rate at 25 degrees,
And we divide
at
it by
15,
4.
it'll be half of that, and at 5, it'll be half of that again. So it's 2 squared that we're dividing it by, which happens to be 4. So you can see it's going to be close to 1 because 3.8 is so close to 4.
Yeah.
3.8 divided by 4 will give me 0.95 molarity per second. So that is the rate at this lower temperature. Any questions, Martin?
No.
Martin, you are just the Coolio-ist
Thank
of
you.
all Coolios.
Isn't my pipe totally hip?
Yeah, lung cancer. So attractive.
Please, lungs.